A point is moving along the graph of the equation below in such a way that the y-coordinate is decreasing at a rate of 2 units per second. At what rate is the x-coordinate changing when x equals 1.5? In this scenario, we have an equation, y equals x cubed, and a point is moving along this graph at a rate of negative 2 units per second in the y direction. And that right there, this 2 units per second, this rate, tells me that this is a related rates problem. So when we take the derivative of this equation, we need to take the derivative with respect to t. First, let's write down what we know. We know that x equals 1.5. We also know that the rate of y, dy dt, is 2 units per second. So now we can go through and take the derivative of our equation y equals x cubed like we normally would with implicit differentiation. So the derivative of y is just 1. The derivative of x is 3x squared. But since we're taking the derivative with respect to t, we need to tack on the dy dt and the dx dt immediately after our derivatives of x and y. All we need to do now is substitute in what we know into our equation, that is x equals 1.5. The rate that y is moving is negative 2 units per second. Put that negative there. And then we can solve for what we are trying to find, which is the rate x coordinate is changing, which would be dx dt. So substituting in our numbers, we have negative 2 on the left for dy dt equals 3 times 1.5 squared for x dx dt. The right side of this equation simplifies to 6.75 dx dt. The next step is to divide both sides by 6.75, giving us negative 2 over 6.75 units per second for our rate of dx dt. And the very last thing that we want to make sure we simplify is that we don't want a decimal in our fraction. So if we simplify this fraction so that there is no decimal in the denominator, it simplifies to 8 over 27, negative 8 over 27 units per second. And there is your answer.